30 to 50% of your fractures produce 80% of your hydrocarbons.
That lends a lot of credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
But I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. Don't do that.
Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hello everyone. Welcome to the Locksmith door. I can't say it.
The door locksmith.
The door locksmith.
know why it would have done that. Just have to put it in there and then take it back out. Plug yours back in. Plug mine back in. Boom, 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 boom. Typical door locksmith show stuff, right? Typical oil field stuff. Something breaks, something doesn't work. You just don't get mad. Don't yell at people. Just
Roll with the punches.
Roll with
That's
the
it.
punches. Got to keep going. All right, there we go. All right, guys. I hear you now. All right, there we go. There was a clunk when you touched the cable. Still muted. Okay. All right, guys. Leave it to a driller to fiddle with stuff. All right, guys. Did I hit the wrong camera?
On the big one, yeah.
Oh, are we on that one?
We're on the big one right there.
Oh
Yeah,
my
there we go.
gosh, why is this one not working now? All right, let's go back to that one. Or we could at least let people be able to see us. All right. Why did this one turn off? Okay, camera 2. Okay, ready. Thanks. Sound working. I hear you now. There we go. Okay. Hooray, mic is on. All right, let's start this over. One more try. Hello, everybody, and welcome to the Vidor Locksmith Show, where we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, and one technical script at a time. It might even be multiple technical scripts. Camera not wanting to stay on, audio not wanting to come on like it should, so I should probably check the lights next time. We do have plenty of battery. We do have plenty of power. Hopefully, it's not too loud. It does look like it's coming in just a little bit hot. But if that's the case, guys, let me know and I'll turn it down a little bit. So just like I said before, we are live in Anchorage, Alaska. Granted, you guys didn't hear anything I said earlier unless you guys know how to read lips. We are live here in Anchorage, Alaska, getting ready for what will be tonight's Anchorage SPE barbecue.
Correct. Yeah.
SPE barbecue technical. I want to say technical section, but that's just DSATs and ICWSA stuff. All right, so guys, let me know where you guys are watching from. We'll give you guys a shout out here on the screen. We'll try to go through and do this one more time. So yes, we had somebody already typed in Corva before the show even started. So thank you for that. John DeWart, thank you for being here. Matt Williams, if you're there tonight at the SP event, please come stop by, say hi. Robert Estes from says good morning. Thank you for being here, sir. And then everybody told us no sound, no sound, no sound. Are you muted? All right. Ian Persh, thank you for watching, sir. Oh my gosh. All right, guys. I don't know. Hold on just a second. Why is it wanting to shut off? Let's try this one more time. Why would it want to do that? It's not hot. So I don't think it is.
I think it's the disinfectant wipes. That's what's causing it right there.
Soon enough, I will have. Soon enough, guys. Don't worry. Soon enough, I'll have somebody that's helping me out with this. So I'm hiring another person to be able to help out with everything. So, all right, yeah, everybody's saying no muted, no muted. Clunk. Okay, I hear you now. There we go. Good afternoon. I'm sorry I can't not hear. Please, could you connect the sound? Yes. There we go. Michael Gaines says I hear you now. Sound working. Sound okay. Ready. LinkedIn user says the mic is on. You know, this is how you get more comments on a show, is you just make things go wrong and then everybody starts to it said SD card. Not sure if that matters. You know, if we put the SD card in there, then we can't live stream it out. So all right, says Jose says hi from Venezuela. Sound is working. Are you streaming on YouTube? Yes, we are. And if this thing turns off, it says I don't need the SD card. That's not what we're doing right now. Okay. Amber Brill says watching from Michigan. And Michael gives props for pushing through and hanging with, watching from H-Town. And then Andrew watching from Houston as well, where it's 82 degrees Fahrenheit, 28 degrees C, my favorite conversion. Oh, I see that. Cool. All right, guys. Thank you all so much for watching. Thank you guys so much for tuning in and being patient with us. Let's go ahead and do the giveaway for this week. I don't have any drill bits on hand, but if you want to win yourself a drill bit, type in hashtag Corva right now into the comment section, and we will do a drawing in just, wait. Oh, did I even turn it on yet? I did not. Okay. Now type in hashtag Corva. Then we'll be able to get it. And then Vadim says he's watching from the 15th floor. I know exactly where you are at, sir. Thanks for being here. Appreciate it. All right. Let's get this going. Let's try to do this. Let's get one thing right on today's show. So type in hashtag Corva. There you go. Type in hashtag Corva. Your chance to be able to win a drill bit. And thank you so much for the partnership that we have with Corva. This is your Corva Insight of the Week.
Torque and drag has always been a challenge that the industry has faced, even more now as well as becoming a lot more complex. Even though we spend a lot of time modeling and planning for worst case scenarios, we still find ourselves spending a ton of time combating these issues throughout operations. Now, this is an area I think we could really improve on. And one way to do that is finding better ways to maximizing the use of all the real-time information coming from the rig side. Doing this has not always been easy though, because in the past, we always had the data, but unless you had a team that was dedicated to monitoring all the information coming in and updating the models, staying on top of these trends was very manual intensive. We now have the capabilities that conducts the interpretations of all your data for you, signaling when and where you picked up, slacked off, and ringed in and out of the hole. More than ever, complex information can be simplified into quick and valuable insights, allowing all the personnel at the rig to remain in a more proactive mode versus reactive. One thing to think about is how are you maximizing the use of your data to overcome the torque and drag challenges that you may be experiencing across your operations?
All right, guys. Thank you all so much for that. That was your Corva Insight of the Week. Let's see if we can get through this without too many other difficulties. Add to stream. We've had 11 entries so far. We go ahead and hit the little button and draw. Let's see who the winner is for this week. Uh-oh, somebody's at the door watching us. And Jose Marine, give us your address and we will get what's happening on but as soon as we do get one, we will get that over to you. All right, so let's remove that. All right, there we go. Now we can get on with the show, and hopefully the camera will stay on for the entire course of the interview. Do appreciate everybody watching. If you guys do have any questions, please let us know. All right, you've already been here, but normally you're out of not on screen. But Mike, thank you so much for being here. I do appreciate it.
Thank you for having me, for sure. Yeah, definitely. No, it's great to be on, for sure.
All right, guys. So if you guys have any questions that are in regards to, let's say, drilling fluids, drilling automation, the future of drilling fluids, any of that stuff, be sure to throw them out. This is the expert. This is the guy to be able to ask. So for everybody that's watching and doesn't know you, give us a little bit of your background and how you got to where you are today.
Sure. No, I started off, I guess, out of college going into the automotive industry. I'm from Michigan, so that was kind of the natural progression is going to automotive, and started with a machine tooling company that worked there mostly in automotive, a little bit in the biomed kind of industry. From there, 2007, I joined Newpark Drilling Fluids as a mud engineer, worked out through the Rockies for most of my early part of the career. About 2011, I started on the technical team there, so I started working more international work, going through places like Canada, Italy.
Oh wow!
Northern, or I guess other European cities or countries there. A little bit in North Africa, a little bit in China, and that kind of took me into what a lot of people seen as the evolution drilling fluid system that Newpark Drilling Fluids had, and I joined that team, and again from there, really progressed across the globe, Australia, lots of different places with that different system. 2016, I started as a more of on the eastern European kind of technology side. And in 2019, I joined Conoco, came up here, moved to Alaska, and have been here since working on operations here in the North Slope.
Oh, wow. So you've seen like every corner of the globe and of the industry, it seems like. Wow, that's absolutely amazing. Let me ask you this, to be able to start off, what is the biggest difference that you've seen in drilling fluids from when you started your career to where you are today?
So I think that there's been a lot of chemistry updates, right? Little things, little incremental changes on the chemistry side through the products. But the biggest thing is we're starting to see more automation within drilling fluids. And I think that's really the future, the next steps, trying to eliminate some of the more mundane tests and allow those mud engineers out there on the rig site to be more analytical. I think that's really the progression and where I could really see it going forward.
Do you think that that's something that's been holding back either the drilling operations as a whole, or at least just the mud engineers, is them having to do some of those mundane tasks as opposed to being more analytical?
I think there's a mix. There's a big mix there where you get some of those mundane tasks and some of the modeling, right? It's really a manual process to do a lot of that modeling. Well, now with some of this automation, it can really change that modeling side where now things are much more automated and allows them to be a lot more technical out there on the rig site.
So take us through that. Like, what is some of the automation that's starting to take place, and what were the steps before that? So let's take like what are some of these mundane tasks that have been focused in on to be automated?
Well, I'd even say, starting my career in 2007, we still had a lot of hand crank rheometers out there in the field, right? I mean, you're doing viscosities with, manual power even in some of these locations, and stepping that up now to some of these automated mud skids that have, either inline pipe viscometers or built-in, rheological devices that are now on the, in the field that you can feed back into your, I'd say your industry software, because I think it feeds into Corva, it can feed into Paysons and Totcos, it can feed into a lot of different pieces of software out there now, and it eliminates that need for a mud engineer to go type these things in and distribute those checks out.
Does that also help with the accuracy of the data? Because I know that there were times in the past, as far as like checking mud weights and stuff like that, it was a derrick hand.
Yeah.
I was like, some may see it not as a high responsibility task, but it was like, that affects a lot of things at the drilling site. You'd probably want somebody who's very technically competent to be the one doing. Nothing against, derrick hands, but at the same time, like,
it becomes difficult, right? It's a difficult task. And I wouldn't say, I don't know if it's accuracy, but you get a lot more sampling now. So any of those blips that you do happen to see, you've got that sampling to kind of cover you for that accuracy side.
And so what does that open up? I mean, other than just, being able to give more time back to the mud engineer, what are some of the other possibilities that we can now explore or just be able to capitalize on?
Well, I even think of, you take it back to those, the pit hands or the derrick hands that are out there, doing a lot of the work with the mud, where they are measuring viscosities or mud weights. And by viscosities, I mean, a lot of that still goes back to a typical funnel viscosity when they're on the rig site. Now we're getting an actual true rheological profile from these types of devices, and more, I don't want to say real time, but near real time type sampling. So you can eliminate that need from that person, which they're trying to do a lot more. I mean, just like anybody in the oil field now, you're doing a lot more with a lot less people. So you free up some space, both with your with the roughnecks out there on the field, and also with the mud engineers, being able to do, maybe some more analytical stuff, and then being able to pull some of that data back into places like a real-time center where you can start to see where some of these potential issues might pop open.
So can you give us any idea of some of the things that you've done with some of the real-time data?
Yeah, so I would say a lot of it has been more so right now. I think we're still in a lot of that testing phase where we're collecting the data. So we're doing the checks out there in the field, but being able to incorporate that now back into software where we can automate that software is really that next game changer. And I think we're just starting to get over that hump. So you can get to that hydraulics modeling where it is more automated and be able to give that to some sort of a well site advisor or a real-time center and let you know, hey, we are getting in trouble here with our hydraulics. We need to either change a mud property, increase or decrease our flow rates, or make some adjustments there to potentially clean a hole or improve our cuttings transports or improve our hydraulics.
What is something that you want to be able to achieve with the data?
To me, so I take the step back of, okay, if we can automate some of those things, that's a lot of manual process with a mud engineer. I now can start putting some analytical devices out there in the field. So if we do want to get a little bit more technical with our product concentrations, we could start to get true measurements out there in the field where historically we have to grab samples, send them to typically a Houston lab, and maybe in 2 weeks, maybe in a month, maybe 3 months, you get some results back. So it makes it real hard to make adjustments with your drilling fluid system, trying to work that model. Now, if we can make that,
there's usually not 3 months in between runs.
Yeah. So 3 months could be, that's like 3 wells, right? Or in some cases, that's 6 or 8 wells.
Yeah.
So it takes a lot of time before you can actually implement and see what that improvement to the process is.
That's awesome. All right, guys, if you guys have any questions, be sure to throw them out there. We'll want to be able to get these over to Mike. I believe we already have one question here. I apologize. I do not know how to read your name, but here we go. What is the best way to develop mud engineer competencies?
Well, I think this is one cool thing that I've seen come out of COVID is we're seeing a lot more teams associated or online training with mud engineers where we historically haven't seen that, right? It's a lot of times it's a mud school where you've got to take somebody's time off the rig, get them into your office, get them in through the labs to actually develop that training. Well, now with some of this online classwork, your training now is to come in and maybe do some lab work. So it really shortens the amount of time that you have away from your job. You can actually start to increase those technical competencies, the chemistry background and those types of things. You start to increase those, while you're even maybe on the job. You can watch the videos and do those things while you're on the job. Where
faster than the internet at the rig is definitely it's gone way up since 2007 when both of us came into the industry. I can tell you that for sure.
So I remember in 2011, I started an MBA and I was working in the field at the time. And it was pretty difficult to get internet, even in 2011, right? The internet was still pretty slow.
Yeah. So walk me through what's the typical course of obviously you just said on how to be able to pick up some more of the competencies, but what is the typical training for a mud engineer? Like, what are some of those milestones that they go through?
So there's a big mix of as far as the entry level type mud engineers, right? We've in typical mud schools, you have people from high level experience from a rig, maybe some roughnecks that had worked derricks and kind of know the fluid side from that side. You've got people with petroleum degrees, chemical degrees, engineering degrees, a lot on the geology side. So you get a good mix when you have a mud school. And then at that time, it's 2 to 3 months worth of coursework, lab work. And then once you get through that, then you get out in the field and typically you're shadowing somebody for a period of time to make sure your competencies are enough. And I would say at that time, then you're put on typical jobs where it's, low stress, low, I would say low competency type environments, where
a little copy paste type of West Texas or something.
Yeah. So you can kind of get your feet and know what to do. And then after a few years, you start to gain that experience and start working, some of these more technical type operations.
What would be a more technical type of operation? Like, obviously everybody can tell I know nothing about the mud side of the business. What would be something that's difficult or more technical? What kind of drilling applications is that? vertical, horizontal, high pressure, high temperature, gas influx, like
it's all of those, right? There's a lot of those different areas where it takes some subtle nuances, right? I mean, if you really start looking back, and what really is difficult is something like, geothermal or 400-degree Fahrenheit type bottom hole wells that you're trying to drill with a water-based mud, right? These mud products that we typically deal with, I would say half of them aren't really on that high end of the chemistry side. A lot of it's low cost, cheap. I wouldn't say bottoms, but cheaper type chemistry, just because it does take so much product, and trying to be in an environment where cost really matters, right? We can't take something that's $80 a pound and mix it into a drilling fluid where it requires tens of thousands of pounds. I mean, it's just not feasible for most operations to do that. Some of the offshore work becomes pretty difficult, right? You're dealing in subsea salt type environments. Some of those have higher temperature. Stuff that's happening in South America now, where they're in massive water depths. That becomes very difficult, because now you're dealing with temperature while you're drilling, right? You're drilling through formation, you got temperature, but now you've got a riser that's getting cooled down, so your mud's seeing much different temperature fluctuation as it's going. Stuff in Europe, right? They do a lot of geothermal work still going on there. That becomes very difficult, because you typically are working with water-based fluids, just because of the temperature and the cost and dealing with lost circulation and those types of things. So there's a lot of difficulties there. Into some of the operations similar to what we have here, where it's more we're not dealing with a lot of unconventional type formations here. So you have a lot more different applications there on the drilling fluid side, the drill in fluid side, and the completion side.
Reason to guess the low temperatures is the challenge on this. It just reform it. Why?
Well, we can shift. It's okay.
I don't understand this camera sometimes. It just wants to do whatever it wants to do sometimes. All right, guys, but thanks. This was the question, and then we followed up with like 3 others there. So thank you for that. All right, Jose says, he just put his address on there. All right, we'll get you a drill bit. Send me that on LinkedIn. We don't need to let everybody know where you're living at. Right there. So Robert asks us, when I worked offshore Gulf of Mexico, 1970s, all mud engineer operations were manual. No automated readings and adjustments to density, chemistry, viscosity made by dumping sacks of powder. What is new?
Yeah, so I would say that there's a lot of new things there that are kind of going on. And Robert, good to see. I guess see you here by the camera, anyways. But there's a lot of new operations where we're taking a little bit more of that approach, where you can automate even the additives, right? There's different systems from different different, let's say, service companies or manufacturers that have integrated these automated type tools out there on the rig site. So automatic sack cutters, automatic mud blending, even simple things like tearing scales out there on on an offshore platform. So now you've got your bulk barite, and you can tear a scale versus having to manually try to measure stuff out. And then taking a step back from there, we start looking at mud plants and some of the automation going into the mud plants. So you eliminate some of the variation that's happening from your fluid system builds.
So you're getting better consistency. Which in a manufacturing style process, that's very important. Now, when one-off instances, not as much, but for multiple well program or whatnot, I can definitely see that. All right, guys, be sure to, if y'all have any more questions, be sure to throw them out there. I do have this question for you. So the mud engineer gets blamed. It's just, it's the running joke of the industry. What is something that you think everybody out at the rig should know that would make the crew better off, or would maybe break that stigma if they just had a little bit more knowledge on that side? What would that be?
Well, I think that's one of the big things, right? Is these fluids are not very homogeneous, right? We try to mix them and we try to keep them, pretty steady as things are going, but the way that we drill, the formations we encounter, water sources we encounter, gas sources we encounter, change that fluid chemistry, and it doesn't always bode very well for the mud engineer. So simple things. I mean, if we just look at density, right? We're now carrying, we drill with a fluid, say it's 10 pounds. We've now carried out a bunch of drill cuttings with it. There at the flow line, it might be 10.5 pounds, right? Because we've got a bunch of cuttings with it. We separate it through a shaker, get maybe half of those out. So now we're 10.2 under there. So now you've got a stream of water going in to combat the solids, and there's constantly that state of flux as we're moving. So I think that's always it makes it an easy target, right? Because it is so much in a state of flux. And just as Robert was mentioning, we're trying to make these measurements, and we're grabbing a sample, making a measurement, and making assessments on that small sample. So until you get a lot of sample sizes, you really don't know what that fluctuation looks like and the variation looks like as we're going through a drilling process.
So in terms of that, you say that, we've got the cuttings coming up. Does it make the job more difficult for the mud engineer if you're not getting to pick the shakers and the screens and stuff like that? Because I mean, I could see where somebody might skimp on the screens, and then all of a sudden, you're either getting more cuttings through or it's cutting too much. Does that have a huge impact on your job out at the location?
Yeah, we try to make recommendations when it comes to those, shaker screens and shaker setups and those types of things, but you're still pretty limited to the drilling contractor, right? The rig is really, you're really hand tied by what's there, right? That's all you've got. And I can make some adjustments there with screen sizes and those types of things, but I still have to manage my flow rates and everything else. So those solids may still get into the fluid, and we still have to deal with them, whether they're reactive or not reactive.
So how much of your time are you looking at the types of cuttings that are coming across? Does that go into your consideration as far as the what blend as far as the mud that you're going to put down hole?
Very, very important. That's a lot of the testing work going up into actually developing that fluids program for a drilling operation is looking at the formation itself, what you're drilling through, the amount of solids that you're looking to pick up, reactive solids, non-reactive solids, how dispersive in nature they are. I mean, there's a lot of different characteristics around that clay chemistry side for sure. And that's the part that I keep going back to on that analytics side. It would be really good to have some more of that analytical component with the mud engineer out there in the field, so we can make some better assessments and better adjustments as we're going.
So what would they be changing at the end of the day if they're looking at, like you said, reactive versus non-reactive, and they're able to make these analytical adjustments? What would be the action item at the end of the day that if they had the time to be able to dedicate to that?
Yeah, so I mean, again, it's so varied, right? The chemistry is going to be so varied across there. But if we look at one thing, say reactive clays, and you want to now inhibit those clays, we can make those assessments on in the field, and maybe it's a concentration level of our inhibitors, and being able to change that concentration level to fully inhibit those clays.
So it's just being more reactive to the things that are taking place, or it might already have been in the drilling program that know that they're going to happen, but then there has to be some kind of, I guess, real-time decision or real-time analytical to be able to say, okay, what did you actually see coming across the shakers, and having time for that as opposed to time dedicated to other miscellaneous tasks.
To measuring a viscosity or measuring a density, right? Those things that can be automated.
Interesting. All right. I mean, it's all good stuff to be able to learn this. I mean, I've got no idea what they're doing. I would just, I'm just in the MWD check. All right. John Dell says automation leads to autonomous. What sensors are needed to cross the chasm or chasm? Here, scoot up just a little bit.
Yeah. So it's really a tough one. I think if we can really get some good viscosity measurements and get it in close to near real time, we can then start automating our hydraulics, which would give us a better assessment of how we're carrying these cuttings, how we're dealing with the simpler tasks, right? The being able to control wellbore breakout, mud densities, those types of things to me would be the low-hanging fruit for us to be able to grasp and automate it. Now, as far as those sensors, I think we're there with the sensoring. To me, it's more so on the modeling side. How do we automate that modeling part of these sensors?
So do you see it being ubiquitous across the industry, where we've got the sensors and stuff out there on the rig site, being able to capture this data and removing that manual labor from either mud engineer or derrick hands?
Yeah, I mean, the few pieces of units that are available, right? What I'm going to just call a mud skid or a fluid skid, those pieces are very, very capable, and we're definitely seeing similar results when you start talking about what a mud engineer is measuring and what's going through that piece of equipment. So I think the variation part there is kind of covered, and it's looking similar to our past processes. Again, that next step, the hydraulic side, is still not very automated. There's still a lot of manual processes where you're taking those results still and plugging them into software, and you need somebody there to do all that work.
Yeah, still need a bartender.
Yeah,
can't have a machine just do all of it.
And again, on that hydraulic side, I think one piece that we've always been missing is our cutting sizes. A lot of hydraulics modeling will dictate one uniform size, and everybody knows that these cuttings are big distributions. I mean, it's not going to be one size on its own, and none of the modeling really takes into account those distributions of cuttings coming out.
So that, to me, that sounds like an open.
There.
There's an open gap in the industry there to be able to start looking at the different cutting sizes
and being able to again automate that part and put it back into that hydraulics program and see that outcome of that distribution.
I feel like there's gonna be like a and this would be the next question, but 10, 15 years from now, there's just like a big skid unit thing. It's got like a little spout for the barite, a little bit for whatever. Barite's like the only ingredient I know that goes into the mud, right? But like it's just got all of those, and it just a little here, a little here, a little here, and then shakes it all up and then dumps it into the flow line or something like that. So what, my being, imaginative brain, what do you see as like in the industry 10 years from now, like the leading edge technology? Maybe not what's ubiquitous across the industry, but like what's going to be some leading edge stuff 10 years down the road?
Yeah, I definitely want to take it to that Skynet, right? Like automated, everything's automated, and nobody has to touch anything, right? I don't think we're ever going to. Well, there might be a point that we get to that, but we're probably a long ways away from robots really controlling our additives and what's happening there. I think eventually sensoring can get powerful enough to where, like I said, the analytical side can get closer to the rig site versus being at a central hub lab type environment, and those sensoring too, the equipment is becoming smaller and smaller. So something like X-ray diffraction, which we look at measuring for some of the formations, these units used to be very, very large, and now you can get small little units that are basically desktop units. So it could be something almost that you could bring out to a rig site to run. So I think that there's a lot of progression going the correct way, but I don't think we're ever going to get to that Skynet, right, where robots are running everything.
All right, let's see here. So that was Joshua. So Robert says automation and the additive methods sounds good, and instrumentation is better, but round trip delays still exist. How would an automated control system deal with the delays? Integrated downhole MWD? ?
Yeah, and that's, I mean, that is a good thought, right? Can we get some of this sensoring or tools in with our BHAs now, and maybe make that more driven from that side, with wired pipe and some of these other things, that it does allow for us to have some more sensoring that could potentially feed back into the mud side.
So what would you want to be able to see measured downhole?
So again, this is a tough one. So where do we pick the low hanging fruit, right? We've got density already downhole. Can we see what our viscosities look like down there? That might be the next step, right? The next natural progression would be, okay, can we see some viscosity and some viscosity maybe profiles at different parts within the well? That would be big for hydraulics modeling. From there, you know, you could start picking off the other quick, easy sensors, right? pH meters are pretty easy handheld stuff. That could be something that could eventually be put, you know, downhole, and maybe we could see a difference between pH or dissolved oxygen or those types of things, you know, on both surface and downhole. Being able to compare what's happening downhole and what's happening at surface. You know, there's a lot of little easy things that I think you could start picking through, and then eventually, yeah, can you get to that? Can you get to that real-time analysis of the formation and know exactly what you're drilling and how reactive it is and how it's reacting as it's coming out of the well?
Well,
Again,
you're talking to an MWD guy and a lot of MWD directional drilling people. So hopefully somebody's out there listening and probably writing down some ideas to things to be able to start. So viscosity downhole is probably the first one, and then pH downhole.
Yeah. I mean, like the pH and just a lot of these are just small little sensors, right? It's small little things that just are.
I mean, that's where it could
need
start.
Fluid to pass through, right? It's a simple sensor.
There we go. All right. Vadim says, David, you stole my question. I'm not sure what the question was, but all right, there we go. So I apologize for stealing anybody else's question. All right. Let's also talk about the SPE locally here in Anchorage, Alaska. Are there other SPE chapters in Alaska, or is this the one?
Yeah, so our chapter is SPE Alaska, but I mean a bulk of the industry is here, right? We've got a pretty large group in Anchorage. There's smaller groups, you know, if you start talking Fairbanks. Then we've got a group up on the slope. That group on the slope is both people that may live here in Alaska, but also may live around the world, right? There's a lot of people that do travel to come to work every few weeks.
Yeah, so not many people living up there.
Yeah, there's not very many.
I mean, unless you're living on the rig. I mean, that's one way to look at it, but yeah.
Not very many living up there, but so locally here, our chapter is about 200 members, 230 members is usually kind of where we're at. And we have we also sponsor the school here. So University of Alaska, of course, all their petroleum departments in Fairbanks. So it's, unfortunately, it's a pretty big distance for us to go there, but we do feed a lot of things back and forth there. And SP Alaska does a lot for scholarships. So we partner with AADE and hand out pretty large scholarships to a handful of individuals throughout the year. 1 year, I mean, upwards of I think $65,000. I think we gave away 1 year, and
wow,
this year everybody that put an application in that fulfilled the application all got scholarships.
Wow.
So it's pretty amazing what we're able to do here with the membership that we've got.
So who are some of the sponsors that are going through it right now? Be able to give.
Yeah,
so that you want to give a shout out to.
I mean,
if you forget any, that's all right. But
yeah, I'll probably forget a few, but I mean, it's
they're probably not watching, so that's okay.
ConocoPhillips and Hill Corp, Gibson
reports.
We've got Schlumberger, Weatherford, NOV, a handful of groups of people here outside of our industry. Skinny Raven donates cards, Costco donates gift cards, Great Harvest, the Trek bike store here donated a bike for silent auction. So I mean, there's a lot of people that are donating for sure. And again, it's both industry and non-industry. Everybody realizes the impact that we have here in Alaska for sure.
So what would you say is the biggest challenge of like working here in Alaska, or Alaska / North Slope? I mean,
so I think the biggest
/ North Slope.
The biggest thing is our logistics here. It's pretty unique. We don't have a lot of operations elsewhere in the world where you've got one ice road to get stuff in and out, where we do have that here in Alaska. So it's a lot of moving, bits, parts, pieces, products from truck to rail to boats to rail to trucks to ice road trucks and roll-a-gons and all these other unique pieces of travel to just to get equipment up to the slope.
How far ahead do you have to be as far as like, because obviously barite is something that's like big, bulky to be able to ship. How far in advance do you have to be able to make sure that that's ordered so that you've got it throughout the year?
Yeah, so it's one of our biggest products as far as square footage, what it takes up there on the slope. But again, it's a commodity product. I know we were talking about it the other day. It's a commodity product that really is low dollars in value. A lot of that cost that we have to get it up here is that logistics side and the support that goes along with it. So it does take a little bit of preparations there to get things up. I would say before COVID, you've got a few weeks, but post COVID now we're really in a world where it takes a couple months now to get stuff onto boats and get it in place. And I don't think we're pretty unique to just drilling fluids. I think this is an industry type problem that we're having up here as far as that logistics and the supply chain side.
Yeah, I know I had talked to somebody else within an organization close to here that had said that, like with all of their casing and stuff, that they order everything like way in advance to be able to get everything up to the slope so that there are no issues. And so, because I was talking to them, previously earlier this year about, oh, did you guys run into casing issues? Because a lot of that was what was happening in West Texas. And they're like, no, because we ordered all of our stuff, 6-7 months ago. So it's just like, to think that you're planning that far out is, kind of strange to me when usually dealing with all the stuff in Texas.
And we do have to do that because we are planning on an ice road, right? That maybe, you may only have a couple months to get stuff across. So you do have to plan that year in advance to really get stuff there.
So to circle back to the SBE and doing stuff for the students and stuff, is that something that y'all work with the students on and be able to start training them up like early on? Like you've got to be able to plan really far out.
For sure. Yeah. And I think that they understand too, just because they are located in Fairbanks, that's a good distance away. And even for some of the events that we create for the students, to come, last year they came down here and did a couple of industry kind of tours, went through several different service companies, some of the tool companies, and able to see what's going on. But even the amount of work that it takes to plan a trip from Fairbanks down is pretty big for for them to understand, right? We've got 2 flights, you've got rental cars, you've got hotels, and it's not as simple as hey, just come check out our facility like it is if you're living in Houston, right? It's a little different.
I mean, you could be living anywhere in Texas. It's like, hey, drive out to Midland, come see your thing. Okay. Or, drive out to Dallas or wherever the things are set up at. All right. So we see here. So we did steal somebody's question. What's the next one here? David, be sure to check out Darwin's Theory while you're in Anchorage. What's that? Darwin's Theory? No, I don't know either. Okay. I'll be sure to check it out. We'll have to go take a look. Also, you need to visit the Great Alaskan Bush Company.
Yeah, I would pass on that one.
Yeah. I don't know what any of these are. So, all right. So before we finish up here, anything else that you would like to tell people about tonight's event? Let everybody know what it is, what we're going to be doing, and who should come out.
Yeah. Tonight we'll be at the Viking Hall here in Anchorage. We'll have a barbecue spread for SBE. Again, this is all to raise scholarship money for next year. Right now we're looking at about, our target is about $20,000 is kind of what we're looking to raise. There's lots of silent auction stuff. There'll be some trivia questions and trivia prizes. We've got barbecue from the smokehouse. We got a couple of drinks there from King Street Brewery. Just a good night out. Bring your family, do whatever, and have dinner and a night and enjoy SBE and donate to our scholarship side.
Excellent.
Yeah.
Well, Mike, thank you so much. For anybody who is in the area that is watching this, please be sure to come out. I will be there this evening. I know that somehow the AADE event is going on at the exact same time. So, if you want to, you can hit up both events. I'll probably be at the SBE one vast majority of the night. I'm going to have a couple of my employees up there with me to be hanging out. So Mike, thanks so much for coming on the show. I really do
having me.
appreciate it.
Yeah, appreciate it.
Guys, next week I will be back in Wimberley. I do not remember who the guest is for next week, and I don't have Tracy in the room to be able to tell me. So be sure to tune in. We've got a lot of amazing shows coming up over the next couple of weeks. I'm going to continue putting together an amazing Vidor Locksmith show as much as we can. And I am so happy that the camera stayed on for the vast majority of the show, at least for the interview portion. Thank you guys all so much for watching. If you guys have any suggestions for the show or anything, please let me know. Reach out, let me know. If you know somebody that would be great to be able to bring on, if there's any other technical topics. Coming up in January, we're going to be doing a torque and drag mini series. It's going to be 7 episodes, Tuesday mornings at 8 a.m. And we are going to educate the entire industry on torque and drag. So we're going to have people like Brandon Foster, Neil Armstrong, Stefan Manon, just to name a few representatives from Landmark, K&M, Oleosoft will all be there as well. So it's going to be an absolutely amazing series. So be sure to start thinking about it. I will be putting out some of the content stuff for that coming up very shortly. So with that, thanks, guys. Thank you, everybody, for watching. Oh, yeah, Brian Gallahan's watching. I do have to throw this out there. Wardrobe today brought to you by AccuScribe. Brian, thanks for tuning in and watching, bud. And I really appreciate this hoodie. It has come in. It's been a lifesaver this week because it is so incredibly cold up here. All right, guys. Until next time, as I always say, let me find the button. Where is it at? There it is. Know your industry.